What are you doing there, bud?
Just running.
What are you running?
Sine of x.
Wow. How's your running been going?
I got a problem and I could use your help.
What's the problem?
I can't figure out my displacement.
Really?
Yeah,
Like at any given point?
at any given point.
Oh my gosh, well I can help you. You're running the sine of x, so sine of x equals Simon, right? So f of x, which is Simon, is the sine of x.
I am the sine of x.
Yes, you are. Now, your displacement at any given point on sine of x is going to be equal to the derivative, which is the displacement, of sine of x. And the derivative of sine of x, as we know, is cosine of x.
So I equal cosine of x.
Your displacement at any point equals cosine of x, like this.
Alright, well thanks for the help, but I still need to figure out my acceleration at any given point.
Why would you need to know that?
Because to know if I'm faster than Devin. What do I say this time?
So as we know from before, your original function is sine of x because that was what you were running.
Yes.
We know that the derivative of that is the cosine of x, which is equal to your displacement. But if you want to find your acceleration, you have to find the derivative of your first derivative, meaning your second derivative.
A double derivative.
Yes, kind of, which is equal to acceleration. And f double prime of x of sine of x is negative sine of x, which means that your acceleration at any given point looks a little bit like this.
Well, thanks for all your help.
You're welcome, anytime. You think I could be a track coach with all this math that I know?
If Brandon Barry can do it, anyone can do it. And that's why, Devin, you should have given me a shout out on YouTube. Otherwise, I would have had to expose you, like I just did, that I'm faster than you. Oh, hey, Sale.
How you doing today, bud?
Pretty good. Thanks to you, I was able to calculate my acceleration on this here white.
Let's see that, man. Hey,
I need your help with another event.
well, what's the event?
I need to calculate the area under the curve that I'm running from 0 to pi.
I can help you with that. Okay, so you can calculate the total area.
Sine of x.
You can calculate the total area underneath your curve by doing the integral of 0 to pi. That's your interval, right? Your first equation is the sine of x.
Oh yeah.
So to
smell it while
calculate
you're stepping
the
in.
area underneath that curve, you have to do the antiderivative, which is the opposite of what we did yesterday.
So a double derivative goes to single derivative.
I like
yes, except for in this one, it's the not derivative going to an antiderivative. So the antiderivative of sine of x is negative cosine x, because derivatives of sine go sine, cosine, negative cosine, and then you have to evaluate that antiderivative of f, big F, which is antiderivative at pi, minus big F at 0 will give you your total area. So let's do, so f of pi is equal to 1, and big F of 0 is equal to -1. So we have 1 minus a -1 equals 2. So the total area underneath your curve is 2.
No, tie shoes.
No, Alex, you don't.
I know, tie my shoe.
Okay. Alright.
Observe it. Well, thanks for the help, but I still need to find out my acceleration at any given point.
Why would you need to know that?
Because
Well, okay.
Alright, we're good.
What you doing there, bud?
Did you see my story last night?